You searched SSH socks proxy because something is just out of reach. The storage controller opens from the office network, but not from your laptop at home. The staging app is bound to an internal address. You have SSH to a bastion, but no full VPN, and you do not want to publish the admin interface to the internet for 5 minutes of work. This is where SSH-D earns its keep. It gives one local browser a path through a server you already administer, then disappears when you close the session. Dynamic forwarding exists for a different problem than SSH-L. Local forwarding says, take this one local port and send it to this one remote host and port. Dynamic forwarding says, start a local SOCKS proxy and let the application request destinations as needed. Your browser can open several internal web apps through the same tunnel without you creating a forward per service. In OpenSSH, D 1080 means listen locally on port 1080 and speak SOCKS. In practice, use 127.0.0.1 1080 so only your machine can connect. This is an administration tool for controlled access through your own SSH server, not a magic privacy blanket. Mechanically, there are two legs. First, your application connects to 127.0.0.1 port 1080 on your laptop. That is not the website. That is the SOCKS listener created by SSH. Second, SSH carries the request inside the encrypted SSH connection to host. From there, the SSH server opens the real outbound TCP connection to the requested destination. The destination sees the server as the source, not your laptop. DNS is the part people forget. A SOCKS-aware application may ask the proxy to resolve names, or it may resolve names locally before connecting. If it resolves locally, you have a DNS leak, and internal names may fail. Here are the exact lines. The first command starts the tunnel. SSH-N means do not run a remote shell, just keep forwarding active. -D creates dynamic forwarding. I bind it to 127.0.0.1 port 1080. Then connect as user at host. The second line is a quick test with curl. The proxy URL uses SOCKS5H. That H matters. It tells curl to send the hostname through the SOCKS proxy, so DNS happens on the far side. Without the H, behavior can differ, and local DNS may be used. The third line checks that something is listening on port 1080. When that SSH process exits, the listener is gone. A common pattern. You administer a small environment with a bastion called Jump1. The database admin UI is reachable only from that management subnet at dbadmin.internal. You start the dynamic tunnel to the bastion. In Firefox, open Network Settings, choose Manual Proxy Configuration, set SOCKS host to 127.0.0.1, port 1080, SOCKS v5, and enable proxy DNS when using SOCKS v5. Now browse to the internal FQDN. The HTTP connection is made from the bastion side, not directly from your laptop. When finished, close the browser tab, restore normal proxy settings, and stop SSH with Ctrl-C. Close the tunnel, close the door. The first mistake is assuming browser traffic is covered just because SSH is running. Only applications configured to use the SOCKS proxy go through it. Everything else keeps its normal route. The second mistake is DNS. If the browser resolves names locally, you may leak queries to your local resolver, and private names may not resolve. Firefox has a specific proxy DNS option. Chromium-based browsers usually follow system proxy behavior, so test carefully. Third, do not bind the SOCKS listener to 0.0.0.0 unless you have a deliberate reason and firewall controls. Otherwise, you may offer a proxy to your LAN. Finally, this is not anonymity. Your server, logs, and remote sites still matter. Place dynamic forwarding beside the other SSH tools. Local forward is precise. One local port to one destination. It is easier to reason about and often better for a database client or a single admin panel. Dynamic forward is flexible. Many destinations selected by a SOCKS-aware app. Proxy jump is different again. It helps SSH itself reach hosts through a jump server. A VPN is broader, routing whole subnets, often with central policy, DNS, and audit. Dynamic forwarding is the light tool between one-port forwarding and a real VPN. In this tier, the skill is choosing the smallest access pattern that still leaves a clear operational trail. Try this only against a machine you administer. Pick a VM or server where SSH login already works. Start the tunnel with the command on screen, replacing user and host. In a separate terminal, run the SS check and confirm port 1080 is listening on localhost. Configure one browser profile, not your whole desktop if you can avoid it. SOCKS host 127.0.0.1. Port 1080, SOCKS v5. Remote DNS enabled where the browser supports it. Visit a simple external site, then an internal admin page if your lab has one. Stop SSH, refresh the page, and confirm access ends immediately. 3 beats to keep. First, SSH-D creates a local SOCKS proxy, commonly 127.0.0.1 port 1080, and applications must be pointed at it. Second, DNS is not automatic safety. Use SOCKS v5 with remote DNS support and test with tools that make the choice visible. Third, treat this as admin access, not disguise. Bind locally, use it for specific work, and close it when done. Tomorrow we keep building the SSH operator toolkit, one topic at a time. New SSH Mastery episode daily on this channel, plus the daily ranked CVE brief for defenders.